In this video, we are going to put together writing and balancing chemical equations. By the end of the video, we should be able to write out the formula equations given a word equation and balance it. Let's look at the first example. Magnesium chlorate yields magnesium chloride and oxygen. So basically all we're doing right now is converting a word equation to a formula equation so we can see the subscripts. The first step is to look at that first chemical. In this case, it is magnesium chlorate. Magnesium is a metal, therefore we're looking at an ionic compound. This means we need to find out the charges of each part and then cross them over. Magnesium is a +2 charge, and chlorate can be found on the polyatomic ion sheet, and it has a -1 charge. Once we cross them over, we get MgClO3 with a subscript of 2. This will yield magnesium chloride. Chloride is actually on the periodic table, and it has a -1 charge, and magnesium, like we said before, is a metal. So we're looking at an ionic compound, which is why we're doing charges. Magnesium has a +2 charge, and once you cross them over, you get MgCl2. Then you see that we have a plus sign and oxygen. If you'll recall, oxygen is a diatomic atom, or a diatomic element, which means it exists in pairs, hence the di. So in this case, it's just oxygen symbol with a subscript of 2. Now that we have our formula equation from the word equation, we can actually balance the equation. The first step to balancing the equation is to list all of the elements involved in the equation. In this case, it's magnesium, chlorine, and oxygen. We are going to have to split up this polyatomic ion because it's not there on both sides of the yield sign. So on the left we have 1 magnesium, and on the right we have the 1 magnesium as well. On the left side we have 2 chlorines, and on the right side we have 2 chlorines. On the left side we actually have 6 oxygens. 3 times 2 is 6. On the right side we have 2. So this will actually be pretty simple to balance because we only need to worry about the single element on the right, oxygen. We need 6 of them. So in this case, if we just add a coefficient of 3 in front of the O, we will have a balanced chemical equation. Let's take a look at the second example. Potassium carbonate plus chromium 3 nitrate will yield potassium nitrate plus chromium 3 carbonate. What we're going to have to do now is convert that word equation to a formula equation. Otherwise, we won't be able to balance it. So the first section is potassium carbonate. Potassium is a metal, so we're going to be looking at the ionic compound rules for turning this into a formula. In this case, potassium is found in the periodic table. It is a metal, and it has a +1 charge. Carbonate is not on the periodic table. I can tell it's not on the periodic table because the ending is 8, and there's nothing on the periodic table that ends in 8. So we're going to look at the polyatomic ion sheet for carbonate. This is CO3 with a -2 charge. Now we're going to use the crossover method to get K2CO3. The next section is chromium 3 nitrate. Chromium is a metal, so we're going to use the ionic compound naming rules. So chromium has a +3 charge. I know chromium has a +3 charge because that's what the Roman numeral is indicating, that it has a +3 charge. Nitrate is not on the periodic table. Nitride is, but nitrate is not. So we're going to have to find that on the polyatomic ion sheet. In this case, it is NO3 with a -1 charge. We're just going to use the crossover method, and we're going to get CrNO3 with a subscript of 3. In this case, the parentheses are actually very important. Otherwise, it's going to indicate that only the oxygen has that 3 subscript and not the nitrogen, and then it's going to be very difficult to balance. On the right side of the yield sign, we're going to have potassium nitrate. Potassium is a metal, so again, we're going to use the ionic compound naming rules. Potassium is in group 1, and it has a +1 charge. Nitrate is not on the periodic table, and as we saw on the left side of the yield sign, it has a -1 charge, and it's NO3. Crossover method will reveal that it's KNO3 with no subscripts. And the last section is chromium 3 carbonate. So chromium we know is a metal. We know it's a +3 charge indicated by the Roman numeral. And we know carbonate is on the polyatomic ion sheet with a -2 charge. We're going to use the crossover method and get chromium 2, carbonate 3. Now we need to balance this equation. First, we need to look at what elements we have on each side. Notice that both of the polyatomic ions are present on each side of the yield sign, so we can keep those together, making it much easier to balance. The first atom is potassium. The next is a polyatomic ion, which is carbonate. The third is chromium. The fourth is nitrate. So we have 2 potassiums on the left and 1 on the right. 1 carbonate on the left, 3 on the right. 1 chromium on the left, 2 on the right, and 3 nitrates on the the left, and 1 on the right. So first we're going to balance the potassium atom. On the left has 2, on the right has 1. So on the right we're going to add a 2 coefficient. This will cause them to be equal. So now you have 2 potassiums on each side. However, since we added that 2 in front of the potassium nitrate, we also changed the number of nitrates that we have. So we need to go down and change that to 2. Now we have equal number of potassiums on each side. Let's look at carbonate. We have 1 on the left and 3 on the right. So we need to give a 3 coefficient in front of the carbonate molecule. Not only does this change the carbonate to 3 on the left, but it also changed the potassium to 6. So now we have 6 potassiums. So we actually need to go and change the coefficient of the potassium on the right. Instead of 2, we now need to change that to 6. So our potassiums are both 6 on each side. However, our nitrates now have 6 on the right. So now we need to go change the nitrate. So we have 3 subscript behind the nitrate. So we have 3. And so we just need to add a 2 in front of that chromium nitrate. Now we need to check the balancing. We have 6 potassiums on each side, 3 carbonates, 2 chromiums, and 6 nitrates. So it's actually now balanced.